Today, I will be discussing what Latin squares are, how they work, an example of them in engineering, and a ANOVA table use of Latin squares. Latin square designs are grids that are like those used in Sudoku. Where Sudoku has numbers, Latin squares have letters of the Latin alphabet giving them their name. Only one type can be used in the same column, row, and diagonal. The Sudoku table on the left is not a Latin square, just similar in structure. The central table is of Latin square design, and the right table is a Greco-Latin square design because of its Greek and Latin letters. In statistics, Latin squares can be used for three-factor analysis of variance, or ANOVA, or ANOVA. When using Latin squares to analyze data, the rows, columns, and individual units each represents one of three factors. To use the ANOVA table from Latin square design, the experiment requires three factors and that each is available in the same quantity. Each column represents factor 1, each row factor 2, and each letter factor 3. Here are some examples of Latin square designs ranging from 3x3 to 4x4 to 5x5. In this engineering example, Latin squares can be used to represent data of rocket velocity based on the type of fuel, the diameter of rocket, and the rocket length. The data within each box is a combination of all three factors and gives the rocket velocity data. The unit selected here in blue is the velocity of a rocket with rocket length 2 and rocket diameter 2. The setup of Latin square designs is useful because it allows us to easily isolate each factor in an experiment. To use Latin squares in ANOVA, just sum up the squares of each row, each column, and each treatment, or diagonal. The degree of freedom would all be n minus 1. This data can be then used to make the appropriate calculations needed for the ANOVA table, other than the sources of variation being listed as rows and columns. Latin square designs are used to simplify the data collection process, especially if the collection of data needed to satisfy each combination of these factors would not be efficient with a given time or budget. Today I discussed what Latin squares are, how they work, an example of them in engineering, and ANOVA table use of Latin squares.